record this? Oh my goodness.
And that was such a beautiful speech.
Isn't it? It was just such a beautiful thing, and I didn't even have it. Okay, so listen please. This top one, if I wanted to graph this thing on the calculator, notice that when I go to the place where I graph stuff, the y equals button, the y editor we call it, the y has to be by itself. We don't have a choice. It only graphs stuff, it only graphs functions where the y is isolated. So algebraically, what would we have to do to that top equation to get the y by itself?
Get rid of.
Okay, I got to get the x off of that side, right? So the first thing I would do for this, if we're doing just this first equation, the first step would be what? Okay, I'm going to subtract 2x, so I'm going to get negative 2y equals negative 2x minus 8. Now what? Okay, now I could divide both sides by negative 2. And just a quick little hint, I'll share something with you here that's kind of helpful. If I ever want to divide an expression that involves multiple terms, if I want to divide that by a common denominator, all you ever have to do is just treat the terms one at a time, right? So for example, negative 2x over negative 2 is x. Okay, so I'm going to get, on this side, I just get y equals, here I get x, and now if I scoot, oops, not that, if I scoot this guy, come on, scoot this guy over here, block out the first term, what's negative 8 over negative 2?
4.
Okay, you get the idea, right? But that's not a lot of work, but it's a little bit of work. The good news is you don't even have to do that on the calculators. You don't have to get some answer that's nice and neat, y equals mx plus b form. All you have to do is just get the y by itself and not worry about cleaning it up or simplifying. The calculator doesn't need it. It's pretty smart. You can handle it unsimplified. So instead, we can just do, oops. There we go. Okay, so instead, on the calculator, all we have to do is just isolate the y into the calculator. So what I mean by that, if I pull up my calculator over here, all I have to do is get this y by itself. You already told me the steps. The first step was to subtract 2x from both sides, right? Okay, I don't have to put the x term first. I already had a negative 8 on that side of the equation, so just leave it there. On the calculator, what's that look like? Well, and then the last step was to divide, and we ended up with a fraction. So on the calculator, I'm going to show you two ways to do this. One of them is going to be to use the fraction template. If I just go alpha F1 and choose a fraction template, if I'm trying to get the y by itself, I just got rid of that 2x term. On the other side, I've already got a negative 8, so I start with that. I subtracted 2x from it, right? And now what's the last step? Divide the whole thing by negative 2 to get the y by itself, right? On the calculator, that just means I go down to the denominator, put a negative 2 there. That's what it means to divide the whole thing by negative 2, right? I don't have to clean it up. That's it. If I just go zoom 6, there's the line. It doesn't need to be nice and neat, right? All you're doing is just getting the y by itself into the calculator, starting with what you already had on the other side. Okay, what about the bottom equation? Let's do that one. Let's do it without using the fraction template. I actually prefer to not use the fraction template. So if we don't want to use the fraction template and I want to get the y by itself, I'm just going to, instead of breaking it into a top and the bottom, I'm just going to put the whole numerator in parentheses and then divide by the 2 that's in front of the y. Agreed?
Agreed.
So if you're not using the fraction template, and you don't even have that choice like with an old calculator, with the TI-83 for example, you have to do it this way. Just open up a set of parentheses, start with what's already on the other side opposite the y, so there's already a 4 sitting there. I'm going to subtract a 2x to that side in the bottom one, right? So minus 2x, close the parentheses, and then that's my numerator. I'm going to divide that whole thing by 2 in this case, by that 2, right? So just divide by 2, and it accomplishes the same thing as using the fraction. Everybody see that? I think it's actually a little quicker to do it that way. So now if I hit zoom 6, there's the first line, there's the second line, and we're just looking for the intersection. Okay, now the nice thing about this, what if the intersection is off the screen? What do I have to just do to... I got to just make the window a lot bigger, right? The nice thing about using lines are infinite and straight. So do lines look any different if I zoom out? They don't. They're still just straight, right? Straight and infinitely long. It doesn't make any difference what scale you look at them on. They always look the same. And so if, for example, these two lines, I could see that they were going to intersect, but let's say it was like someplace way up there. All I'd have to do is just make the window really big. I mean, I can watch what happens if I go to the window and I make it really large. And keep in mind here, when I'm graphing something on the calculator, remember what the parts of the window mean. X minimum is just over here, right? That's just the left edge of the screen, right? See, why can I sometimes draw on this thing and sometimes I can't? That's really strange. I don't get it. X minimum is over there, X maximum is up here, Y minimum, Y maximum. Well, if I make X minimum like negative 1,000, okay, I'll make X maximum positive 1,000. Now, if I had like parabolas or something, that might make them look really bizarre because they're curves and it's going to distort the curves. But if I'm just doing lines, watch this, it doesn't change things a bit. Oops, I messed something up there. No, I just had to hit graph. I made that a 10,000. No wonder. Yeah, I want to make them so I stretch all the parts equally. There we go. Try that. So it jammed all the little tick marks together on the X and Y axes, so they look like they're real thick. But other than that, it looks pretty similar, doesn't it? Right? They just look like lines. And so as long as I can see the intersection on the screen, the calculator will find it very quickly for me. Okay, here's how you do it then. Once you can see the intersection visually, you just go second, calculate, so second F4, and then you choose intersect. And then we've done this stuff before, remember? But before we had to be a little bit careful. We had to hit enter twice and then make a guess. We don't even have to. Because if I can see one intersection, how many intersections are there? One. I don't have to make a guess. There's only one intersection to choose from. So once I hit second calc 5, once I choose intersect, I can just go triple enter and I'm done. Hit enter 3 times. There it is. That's the answer. Okay, how about that?
Why does it keep going quitter go to?
Say that again?
Why do you keep saying quitter go to?
Okay, hit go to then, because they'll tell you what's wrong. Hit 2. Okay, so that's a minus sign. Yeah, that's easy to do. Okay, makes sense? Makes sense? Okay, so listen please. So when you take the test at the end of Unit 2, there is going to be a graphing calculator part of the test, which ought to be a pretty easy test. All that's going to be is, among other things, you have to do a few other things too, but you're going to have to, if I give you a linear system, you're going to have your graphing calculators available to solve the linear system by graphing, okay? You got more of these for me? Okay. Thanks, all right. I have to pass them out. I'll pass them out in a second. Okay. So try one of these on your own, please.
No.
So that was our
Oh,
answer,
yeah?
right?
Is there,
What's that?
is there different types of infinite?
Yeah.
Which is the biggest?
That's a very good question, actually. Oops. Well, like for example, infinity times infinity is bigger than infinity plus infinity.
Yeah.
It really is. They're both infinite, but one of them goes there faster. Okay, try this, please. Listen. Try this on your calculators. Try that. Isolate the y's into your calculator. See what we get. Well, I pass these out. Yes, congratulations. Just, whoops. Diana, what did I do? Oh, you got one for each? What the heck?
Oh, it's just not really popular.
Yes, you are. Yeah.
The bitches love me.
Whoops. Quick save, huh? Okay, did we get this?
No,
Still working on it.
Okay. Okay, while you're working on it, I'll pull up the graphing calculator and.
Do you want to do equation fraction?
However you prefer.
And the bread.
Increases my chance.
Okay, should we try it?
I only got one line.
Uh-oh.
Why is my screen so not
What'd you do wrong?
Why is my screen so not right? What's wrong?
What's going on?
I know, mine's doing the same thing.
Uh-oh. Okay, take a look here. Maybe did we break the calculators? What's going on?
No, you have to.
Oh, okay. Okay, so
I zoomed out.
now let's be problem solvers here. If we see one line there, what are the two things that could be going on?
Same line.
Could be the same line, or could be another line that's parallel to it off the screen.
Yeah.
Okay, now before you start hunting around for another line that's parallel to that one, there's an easy way to check and see if the two lines overlap. Okay? Any ideas how we could do that? And you gotta you'll see how good at detectives you are. What can I do here? No?
You pick like two.
Okay, actually, you know what? I think that'll work. That's a good idea. No one ever suggested that. That's pretty good. Okay, so try this. This is an experiment. If you hit intersect, let's just try this. I think this might work. Second calc 5, and if I hit triple enter. Okay, no, look what it did. Whatever x value that cursor was on, it went to the line for that x value, and it gave me an answer. Okay. Now this is kind of an experiment. I've never tried this before, but I think this is going to work. That might be a way. We're going to try one more example like that. We'll see if it works. That's one possible way that you can tell, but there's another way too. If I go to y equals, now when I want to graph both of those two lines, I have to highlight both of the equal signs. The calculator does that for me. So if I were to graph, let's say I wanted to graph 4 equations at the same time. If they were all highlighted, if all the equal signs were highlighted, it would graph them all. But I might just want to look at 2 of them at a time, and the calculator allows me to do that. By unhighlighting an equal sign, it effectively turns that graph off. So what happens if I turn off the first equation and I hit graph and it looks the same? Now what is that? Just unhighlight the equals. Okay, it looks the same. So that still could mean though, couldn't it, that this was the second one and the first one was just way off the screen someplace. So how do I check? Flip it, reverse it. Okay, if I go back now and turn the first one on and the second one off, if it looks the same, what's that telling me? Same line, right? How about that? Okay. All right. Okay, got another one for you. Let's try this one. Okay, we got that one done. Now try this one. What if we had 2x plus y equals 10 and y equals negative 2x minus 5. Okay, we're going to solve that system on your calculator. Okay, let's try that one. So what am I dividing by in that first equation? 1. I really don't even need to divide, but honestly, this is going to sound kind of dumb, but when you're solving equations into the calculator, I would always go through the same process. I do. I would literally, at the bottom, I would just divide by 1. I just get in the habit of doing that if I'm solving lines into the calculator. Even though I didn't need to, it doesn't change anything. Okay? So what did we find on this one? Bottom one's already done for me. Okay, zoom 6. Line number 1, line number 2. What can you tell me about those lines? Okay, they look parallel, but does that mean they are parallel?
No,
It does?
because they can't.
Because there's no intersection.
Okay, up here, please. Okay, so how can we tell for sure? Because it's possible. Now, we picked lines where we could probably reason this out a little bit, but what if those were really weird lines? What if they involved lots of decimals or big fractions? It might be hard for us to tell if they truly are parallel or if maybe they actually just look almost parallel and maybe they cross way down there somewhere. There's a way I can tell for sure, though. If they are parallel, what would have to be true about the two of them?
Or they don't.
They don't have an intersection, true, but what else is true about two parallel lines?
They have to have the
Same slopes. Now, here's a way you can check the slopes of the lines. Watch this. If you go second calc, and none of those say slope, but number 6 means slope. dy dx, what that means is change in y over change in x. So like y2 minus y1 over x2 minus x1. It's a shorthand. It's actually a calculus way of saying slope. So number 6 means slope. Now watch this real quick. I'm going to show you how to use this. If I hit number 6, okay, right now, notice that the cursor is up on that first line. If I go to the right just a little bit, you can see the cursor? It's on the first line. It's on y1. If I hit enter, it's going to tell me the slope of the top line, the first line. How do I switch between lines? Well, if I use the up and down arrows, that toggles between the different lines. If I hit down, look, it jumps down to the bottom line. And so now I can find the slope of the bottom line. So being as we're already on y2, let's find that slope. If I hit enter, it tells me that the slope is -2. Okay, we knew that though, didn't we? Right? Let's find the slope of the top line. So I'll hit second calc 6, and I'll hit the up arrow. Actually, it's already on y1. So if I hit enter, it tells me that the slope of the other line is also -2. So there, the slopes are equal. So we know that they are different lines. I mean, that they are parallel, right? Make sense? I'm gonna do a test here. If I go calc,
I tried it.
5,
It was like error.
okay, so it does, because if it gives us back an error,
Nolan, bilingual, come to the office.
if it gave us back a point, there's the same point. That's good. That's the only time in all my years of teaching I've ever done it. That's pretty good.
Oh yeah. I think I broke this.
Think you broke it?
Not actually, but like
Listen, all the
I
cool
was messing around and I put in a graph